Welcome to another edition of Technical Quick Tips. I'm Bob Schmid. Today we're going to talk about the SOA, or Safe Operating Area curves for the PCO-7121 laser diode driver. This device has specifications of 50 amps of output current, up to 1 megahertz pulse repetition rate, and up to 1 microsecond pulse width. However, you cannot get all three of those items at the same time. Recall from our first video that when you pick a current and a duty cycle, you are setting an operating condition that has to fall within the safe operating area curves. So at this point, let's take a look at the SOA curves for the PCO-7121. You can see that on the horizontal axis, we've plotted pulse width in nanoseconds. It starts at 22 nanoseconds, it goes up to 1 microsecond. On the vertical axis, we've plotted the frequency of the pulse, or the pulse repetition rate, going from a low of 1 kilohertz up to 1,000 kilohertz, or 1 megahertz. And the colored lines represent output current. Let's take a couple of rather obvious examples. First of all, the uppermost blue line represents an output current of 5 amps. And you'll see that the line is basically horizontal. So if we pick a pulse width of, say, 200 nanoseconds, that takes us to the very top of the curve. And as we can see, we're allowed a frequency of 1 megahertz, no problem. But let's take an opposite case. Let's go to the bottommost curve, which represents 50 amps. If we want to use a 100 nanosecond pulse width, projecting that to the left on the vertical axis, we're probably sitting at perhaps 12 or 15 kilohertz maximum. Let's say that we wanted to go faster than that, and we wanted to move up to, say, 20 kilohertz. Projecting to the right, we find that we can no longer run 50 amps. We would have to run probably 45 amps or so to maintain that same 200 nanosecond pulse width. If we look at the horizontal axis of pulse width and compare that to the vertical axis of frequency, we sort of end up with a duty cycle. If we think of the vertical axis as being a period, or 1 over frequency, we can see that as we go vertical, we are going upper in frequency, but slower in period. And consequently, we would expect those curves to bend a bit downward as they do. These curves are composite curves. They're made up of watching the dissipation of a number of different devices on the board, making sure that we don't over-dissipate any one of them. So keep in mind, you can operate within those limitations on the data sheet. However, certain combinations are above the SOA and must be not used. Everything below the lines works just fine. If you have any questions, please contact our customer service department. Thanks for watching.